I'm Justin.
I'm Henry.
I'm Noel.
And I'm Arafat. And for our design project, we decided to create a low-profile scissor lift that would work on lowered cars.
For our geometric design, we emulated a scissor lift mechanism. We designed it to be thin enough to, when fully collapsed, to be able to fit under any low clearance vehicle. The lift utilizes either a motor or a screw to push link 4, which is connected to the X-bar mechanism, which outputs the mechanical advantage of lifting an object.
For the force analysis portion, we wanted to find out how much force was needed to lift a 2,000 kilogram car. We did this by finding the force needed to push pin A through the slot when the lift was close to maximum height. Since the lift was symmetrical, we did the analysis in 2 dimensions and assumed the weight of the car was at the center of the lift. We made free body diagrams for the links and used those to derive force and moment equations. We found that the lifting force needed was about twice the weight of the car, so that gave us a mechanical advantage of about 1/2. But the lifting force and mechanical advantage changes throughout the range of motion. To improve this, we could use a long ratcheting handle on a lead screw with plates that would push pins A and C together.
For the stress analysis portion of our design, we performed our analysis under the assumption of idealized conditions in the materials properties used to create the lift. That is, the materials to be homogeneous, isotropic, and have relatively equivalent tensile and compressive yield strengths. Here, highlighted in red, is one of the most likely points of failure as the lift is raised to its maximum extension of 23.62 inches. At this point, the inner surface enclosing the rotating pin experiences a region of compressive bearing stress. From our analysis, we calculated that the bearing stress at this point would experience a load of 128 megapascals and have a factor of safety of 1.13 using A36 mild steel. For comparison, we compared 2 other grades of steel, namely A572 grade 50 steel and A283 grade D steel, and found their respective factor of safeties to be 1.55 and 1.04. If price and weight was not a factor, our lift would be made out of A572 grade 50 steel because of its high strength properties. Unfortunately, cost and weight was a factor, so A36 mild steel was used instead.